Today we're going to be starting 6.2, which is also going to be talking about quadratic equations like we had before, but now we're also going to include something called absolute values because they're kind of done and solved the same kind of way. So we're going to talk about both of these. Quadratic equations you should already be familiar with from 6.1. So we're going to work with that a little bit later, and then we're going to start with absolute value. So how do you solve equations that use absolute value and quadratics? We're going to start with the absolute value first and talk about what that means. So what does absolute value mean when you're talking about trying to find the absolute value? And you've probably seen the symbols before, like this little 3 over here. So this means the absolute value of 3. What does it actually mean? It's a very simple definition. When you ask about the absolute value of something, you're trying to ask the distance that it is away from 0 on a number line. The distance away from 0 on a number line. Which is why I included a number line here. So for example, if we saw the absolute value of 3, that's asking how far away is the number 3, if I were to highlight it on here, how far away is 3 from 0? Well, I mean, that might be obvious, but you could just literally count and go, okay, it's 1, 2, 3. It's 3 spaces away from 0, so the answer is 3. Pretty simple. Now, what if it was the absolute value of negative 3? How far away is negative 3 from 0? So here's negative 3. I'll highlight it. Again, you just count back towards 0. It'd be 1, 2, 3. It is also 3. So a lot of students kind of memorize this as no matter what you plug into absolute values, you're always going to get out a positive number. Because what you're doing is you're counting distance, and distance is a positive thing. Now, what if we threw a negative sign out in front of it? Let's get rid of this. If you had something like this, you'd do the absolute value of 3, like we normally do, and then the negative would just sit out there. So we already did the absolute value of 3 over here, and we already know it's 3. So this instance, it would be 3, but the negative's still out there, so the answer would be negative 3, only because the negative sign is on the outside of the absolute value sign. How about 4? How far away is 0 from 0? Well, that's 0. 5. Now we're going to plug a variable in there. The absolute value of x equals 3. So that's saying what number could be in here to give you a value of 3. And it just so happens that there's 2 of them. And we just talked about that in the first 2 problems. What numbers could be in the absolute value symbols to give you the answer of 3? Well, these both give us the answer of 3, right? So the answer could be, x value could either be 3, positive 3, or negative 3. So we have 2 different answers here when you have a variable inside of a absolute value. And this will always happen because you can be on either side of the number line and count towards 0. How about absolute value of x equals 5? So what number could you plug in there? So that would be 5 away from 0. Well, you could be at 5, right? That'd be 5 distance away. You could also be at negative 5. So what values could we have for x? We would say x could equal 5 or negative 5. Sometimes they also write it like this, x equals 5 comma negative 5. It doesn't happen that often. I'd rather use the word or. You could also write it 2 times, x equals 5 or x equals negative 5. They're all valid. This one happens pretty often as well. All right, how about the absolute value of x equals 0? How far away is it from 0? Well, to be no distance away from 0, this one is the only time you would ever have one answer. Because there is no positive 0 or a negative 0. So it's just x equals 0. And the last one, the absolute value of x equals 12. So how can you be a distance of 12 away? That would have to be a positive 12, or I'll do it this way. X would have to be negative 12. So either whether you put positive or negative in here, it's going to come out to be a positive answer. Now, what if, let's just pretend this was changed from absolute value of x equals 12 to absolute value of x equals negative 12. Can you take the absolute value of a number and get out a negative number? Well, no, that doesn't make any sense because absolute value means a distance. You're counting a distance amount. We're not going to have a negative distance. So this is actually impossible. This would be no solution, which I probably should have put a question like this on here, but I just wanted to kind of talk through this. The other side of the equal sign has to be equal to a positive number if all you have left over here is the absolute value sign. There'll be different kind of problems we're going to do a little bit more difficult, but once we talk about the absolute value part, this side has to be positive. So let's try some more, a little bit more difficult, solving for x. So again, all we have is absolute value over here. So this side has to be positive to keep working with it. And so the way we do this, because since we know it's going to be two different answers, we're going to split this into two different equations. We have one answer or the other. So we're going to say that x, and we're going to get rid of the absolute value signs. We'll say x minus 4 could equal 81, or we could say x minus 4 could equal negative 81. So this takes care of the absolute value sign, right? Whatever's inside here is either going to be a positive 81 or it could be a negative 81. And then when you take the absolute value symbols, it comes out to be positive. So this is how you set them up. You just change whatever's on the other side of the equation to either negative or keep it positive. And you're going to solve two different equations, but they're done the same way, right? How do you solve this for x? You add 4. So x equals 85. So if you were to plug in 85 in here, subtract 4, do the absolute value, you get 81. Or the other option, if you add 4 to both sides, does not give you the same answer because now we have negative 81 plus 4. Completely different. A negative plus a positive here is going to be negative still, but now we're at 77. So these are the two options that you could plug in here to get an answer of 81. Again, there's always going to be two answers, unless, of course, there's a negative sign over here. That's bad. No solution. Or if it's actually 0, like we had before back here, 0 means there's no solution. All right, how about another one? So if you look at this one here, we have more than just absolute value here. We have a 4 being multiplied by the outside. We have a plus 7 here. So we have to do some additional steps before we look at this and separate into two different equations. And you cannot do this. You cannot distribute the 4. Absolute value is not actually considered a parenthesis symbol. They're different. They may both be grouping symbols, but it's not parentheses, so you cannot do this. Nope, don't want to do that. So I'm going to get rid of the things that are next to the absolute value. I'm going to get rid of the 7. Since it's plus 7, let's subtract 7. So this becomes 27 minus 7, which is 20. And then we bring down everything else. 4 times the absolute value of 2n plus 7. To get rid of this, since it is being multiplied, and although we can't distribute, since it's being multiplied, we're going to do the opposite by dividing. So now we're in a position where we only have absolute value, and we can do what we did over here by splitting it up. Because remember, whatever is in here, it could be a positive or a negative number. It could be positive or negative 5, and that would give us the same answer. So we're going to split it up into two different equations. We're going to have, and this is the time where you can actually drop the absolute value, because we're looking to just for the inside and saying, what could the inside be to give you 5? Or 2n plus 7 could also be negative 5. And then you just solve those separately. Sometimes you also get decimals or fractions, and that's okay too. In this particular case, I think we'll be okay. If you minus 7 on both sides, we get negative 2 equals 2n, divide by 2. So this gives us a whole number, and it is negative 1. Or, what's the other possibility? If we minus 7. So we do the same steps twice, but it's going to give you a different answer. Negative 5 minus 7 is negative 12 equals 2n. Divide by 2. So n is equal to negative 6. So the first one we did, we actually got a positive and a negative. This time we got two negative answers. So that if you were to plug that back in to the n here and solve this out, you would get 27. And that should work if you tried that. Negative 2 plus 7 is 5. 5 times 4 is 20. Plus 7 is 27. Negative 6 times 2 is negative 12. Plus 7, negative 5. Absolute value negative 5 is 5. Times 4 is 20. Plus 7 is 27. You can check it. That's just a very quick check. But they should work if you plug them back in. Our last thing with absolute values is actually graphing them and see what they look like. And then we'll move on to quadratics. So this actually really isn't that bad if you plug in these numbers over here for x. Like if I put negative 3 in here, right? What's the absolute value of negative 3? We already know. It's just going to change it to positive. So 3. What happens when you plug in negative 2 here? It just turns it to positive. 2. Same thing here. Negative 1, you get 1. If you plug in 0, you get 0. Now what if we plug in positive numbers? Then it doesn't change at all. The absolute value of 1 is 1. Absolute value of 2 is 2. So it's really just the same number, but no negatives at all. So let's see what that graph looks like. So negative 3, 3 is here. It's always hard for me to put dots on here. Negative 2, 2, negative 1, 1, and 0, 0, and then 1, 1, 2, 2, and 3, 3. So what we have is this little shape here. Looks like a V. Let's go a little thicker with it. So it would look something like this. Sorry, it's a bad drawing there. Can't connect. So connect the dots and you make them straight. It looks like a V shape. And that's what absolute value looks like. So let's try altering it a little bit. What if I did the absolute value of x plus 2? So we're going to do the absolute value first, and then we'll add 2 to our answer. So if we do the absolute value of negative 3, which looks like this, absolute value of negative 3 plus 2. Absolute value of negative 3 is 3 plus 2. We're going to get 5. Remember, when you plug that into the x, it just turns it to a positive. So in this particular case, it would be negative 2 going in there, becomes a positive 2. Add 2 to that, it's 4. Plug in negative 1. Positive 1 plus 2 is 3. You can keep going. This will give you 0 plus 2, which is 2. And it looks like we're going to get the same kind of answers. If you look over here, 3, 2, 1, 0, 1, 2, 3, we're going to get the same answer. So if you plug in 1, you're going to get 3. Plug in 2, you get 4, and 5. So let's see what this looks like. Negative 3 is 5. Negative 2 is 4. Negative 1 is 3. And 0 is 2. 1 is 3. 2 is 4. And 3 is 5. If we were to connect these, I'll try it again. A little better that side. Now maybe you notice what happened. It's still that V shape. The original one had that little pointy part at the origin, but now it has been moved up to the 2. Maybe that makes sense since there was a plus 2 here. You can also do this on Desmos. I'll show that to you as well. I don't know how to do it other than typing in the word ABS for absolute value. So if you type y equals and do ABS, then you put a parenthesis there. This means the absolute value of x, so you'll be able to see it. There it is, that V shape. And then I'll do it again, y equals ABS. This time we had x in there, and then we added 2, and you'll see that it goes up a little bit. So if you ever want to type this in and see what the graph looks like in the calculator, or the, I guess, online calculator, you can do that. Just type ABS. All right, for the next part, very similar in how you solve quadratics. There is a huddle that you can do, some graphing, some solving. We're going to go to part 2, solving quadratics, to finish this up. This is done a very similar way. And we're also going to get two answers, and I'll show you what I mean by that when we do it. So when you look at these problems, x squared minus 20 equals 16, we're going to solve this for x. But we had to figure out, well, what do we do with this x squared? So we'll do what we normally do. Just pretend this was just an x here. We're going to bring over the 20 by adding it. Well, that's kind of thick. We'll deal with it. X squared, 20 goes away, equals 36. Oop, kind of ugly. But we are almost done. So then we got to talk about how in the world do we get rid of something that's being x squared here. The only way to get rid of this squared here is well, I'll tell you one thing you don't do is you don't divide by 2. That's not going to cancel these out. That does nothing. Don't want to do that. The only way to get rid of something that's being squared is to, should I tell you? You could do something called take the square root, if you know what square root is. Or, alternatively, you could think to yourself, what number, when you multiply it by itself, gives you 36? That might be a way of thinking about it. So let's just do it that way for this time. You don't need a calculator. What times what gives you 36? And there are actually, again, two answers. So this would be a time where you could split it up and say, okay, what kind of answer are we going to get? 6 times 6 gives you 36. But also, what's the other one? Also negative 6. Because think about taking negative 6 times negative 6. The negatives go away and becomes positive 36. And again, you can write this the multiple ways we talked about. You could say x equals 6 or x equals negative 6. There's also another way you could do this if you have the same number, one's positive, one's negative. You could say plus or minus 6. That shortens it a little bit so it's only one number. Trying to be efficient. Us math people are a little lazy with it. We just want to write plus minus 6 and to know that that's two answers. So there are two numbers you could plug in here and square it to get 36. All right, number 2. This one looks a little weird because we have a squared on the outside. What you cannot do is you cannot square the things on the inside. That is not how this works. We can, however, get rid of this squared, again, by either taking the square root or thinking, what times itself gives you 169? That might be a harder one to figure out. If you have a calculator in your phone, this can do the square root. You don't have to have a one in the classroom. If you do the square root symbol on this side and this side, what happens over here is it goes away and you get 2k plus 7 equals, and over here, you're going to get a number. And now this could be, if you do it in your calculator, it ends up being 13. But remember, when you square a number to get 169, it could be either a positive or a negative, so we get plus or minus. So since we have more work to do, I'm going to separate this into two different equations, right? Like we did with the absolute value. As soon as I get rid of this squared, I need to make two equations. I'm going to say 2k plus 7 equals 13, or 2k plus 7 equals negative 13, which is exactly what we did with the absolute value problems. We separated into two different equations and then solved each one. One's positive, one's negative. So we'll solve them. Minus 7, put a line here. We get 2k equals 6, divide by 2. K is equal to 3. Oh, that's pretty ugly there. K equals 3. So that's one answer. Or we could subtract by 7, get 2k equals negative 13, and negative 7 is a negative 20. Divide by 2, k is negative 10. So those are the two options you could have. Again, you'll always get two different answers, just like the absolute value. There's no difference there. And then we're done. So the last one. This one has an x squared with just x on it. The squared is not on the 3, so it's a little different than this being entirely in parentheses, right? We had this parentheses set that's surrounded by this squared. So this one over here, we don't have that. The squared is only on the x. Now we have 3 times x squared, so we have to get rid of the 3, but we don't have to do the whole square root thing just yet. So what I'm going to do first is I'm going to divide by 3, because the squared is not messing with the 3 here. We're allowed to do this. So we have x squared, and then if you put that into the calculator, we get 729. And now would be at the time where we would separate into 2 different answers, because we got to think of what squared gives you 729. So you can either break it apart in 2 different answers, or you could just say it's a positive or negative, because we know we have nothing else to do. To get rid of something that's being squared, what times itself gives you 729? It's a fairly big number. I think it is 27. Again, you could also do square root on both sides to get rid of the squared, and you would also get 27. So with these ones, quadratics, 2 answers, just like the absolute value. We have one more to do, and then we're done. And the rest of the huddle and mastery is left up to you to try. Number 4, little word problem. A square and a circle have the same area. The square has a side length of 15 units, which is written on here. Which is longer, a side of the square or the diameter of the circle? So we got to see which one is longer. So since they have the same area, big old capital A, so the area that this takes up in the square and the area it takes up in the circle, they're the same. So we can say area of square, write it out in words, equals the area of the circle. So then we just have to think about, okay, well, what is the area of a square and the circle? Let's think about this. The area of a circle, the formula for that is, if you remember from a long time ago, pi r squared, where r is the radius. And so we have r sitting here. And then on this side, we have the area of the square. Area of a square just means you take the length times width. And in this particular case, it's 15. And it's 15 all around, right? It's 15 here and here and here. So to find the area of the square, we just do 15 times 15, which I'll just write it out for now, I guess. And you can multiply that together. I believe that's 225. So we have 225 equals pi r squared. Now we're trying to compare the side of a square or the diameter of the circle. But first we're going to get the radius of the circle, and then we'll compare that to the diameter, which is just the entire way through the circle, the distance. So how do we solve something like this? We're going to divide both sides by pi. You can divide it by 3.14. I'll probably do it that way. So 225 divided by 3.14 looks like it's 71.65. So we'll do 71.7, round that up, equals r squared. And again, we have to think about what squared gives you 71.7, or you can just do the square root symbol. If you are trying to do this in your calculator on your phone, you can actually press, if you do your phone sideways, it will give you some more options. And then you can hit the square root button. It should be on there. Of course, in class, I can show you how to do that as well. So I got, if you do the square root, I got 8.46 or 8.47 if you round up. I'll do 47. And that's the radius. So if the radius is 8.47, what would be the diameter? The radius is 8.47. Maybe erase the rest of this stuff here. So what would be the diameter of it? Going all the way across, you just have to double it. So from here to here is 8.47. So this is also 8.47. So we just add them together. So it looks like it's going to be 16.94. So you just multiply by 2. And then the question is, okay, so the diameter, D, the whole way across, is 16.94. The whole reason we did that is because we're trying to answer the question of which is longer, a side of the square, which means the side of the square is 15, or the diameter of the circle. The diameter is 16.94. So we would say the answer is the diameter is longer. So the radius definitely is shorter compared to the side, but the diameter is longer. The diameter is longer than the side of the square. Of the square. There's a little word problem we did. Not too bad. And so that's all. So you have to kind of know when to get two answers. I guess I should go back and talk about this. The fact that we should have gotten two answers. It's 8.47 or negative 8.47. But in this particular case, when you're talking about a distance, we don't use a negative answer because that wouldn't make any sense, right? To have both. So I kind of forgot about saying you get two answers, but we just kind of cross that out and say, hey, you can't have a negative radius because you're trying to measure how big the radius is of a circle. So we would only use the positive 8.47. So sometimes you have to figure that out based on the word problem that you're given in a real world situation. And that would be it for 6.2, absolute value and quadratics. Now you can finish up the rest with the huddle and the mastery.